Hey guys, take 4 on 4.1 Organizing Data into Matrices. We're going to work on identifying matrices and their elements and also organizing data into those matrices. Let's go ahead and get started. Looking at example 1, let's first look at the definition of a matrix. A matrix is any rectangular array of numbers written within brackets. You have to have brackets in order for it to be a matrix. Um, all matrices, which is the plural of matrix, has a capital letter and it is classified by its dimensions. We classify those dimensions by row and then by column. Okay, so you do row and then columns. There's 2 rows here, so it's going to be 2 by 3. So matrix A is a 2 by 3 matrix. All right, so let's go and take a look at the example that you guys are going to need. There we go. Okay, so write the dimensions of each matrix. Now, A is unique, and because of its dimensions, it's kind of hard to mess this one up. But again, just remember you have rows and then columns. One thing that I had shared with you in class was that you could do RC, and then if you remember that cola, the RC cola, that might help you remember rows then columns. So we've got 2 rows and we have 2 columns. So this one is a 2 by 2 matrix. All right, this one has 1 row and it has 3 columns. So this one is a 1 by 3 matrix. Pretty easy so far, I hope. All right, let's go ahead and take a look at example 2. Example 2, we are learning about the matrix elements. The matrix elements is any number that is represented within the matrix. Okay, and remember, a matrix is named using an uppercase letter. So an element is going to be named using the lowercase letter of the name of the matrix, and then the first sub number is going to be the row. The second sub number is the column. So just like when we name the dimensions, it's RC, row, column. So what this A, lowercase a13 says is that this is an element in matrix A located in row 1, column 3. All right, so let's go and take a look at the ones for the notes. We have matrix K here, and we are going to look for element K1, 2. So that's K. So we want to look at matrix K, row 1, column 2. So that, my friends, is right here. So -1. Okay, now looking at B, K3, 2. So that's going to be row 3, column 2. Row 3, column 2. And that is -4. C, we have K, 2, 3. So that's K, matrix K, row 2, column 3. So here's row 2, and here is column 3. So right here, row 2, column 3. And then finally, we have K, 3, 4. So in matrix K, row 3, column 4. In this case, it is -5. Okay, so again, hopefully easy now that you understand what those different values represent, because before, who knows what K12 is, right? All right, let's take a look at example 3. Example 3 is using a matrix to display data from a real world setting. You are taking the data from a bar graph and you are going to translate that into a matrix like this that's more user friendly as far as expressing that data for papers or for communicating that to somebody who needs to know how much energy production or consumption was used. Okay. All right, so let's go and take a look at the one for your notes today. and we've got 3 students kept track of the games they won and lost in a chess competition. They showed the results in a chart. Write a 2 by 3 matrix to show the data. So I made epic fail on this one when I recorded it yesterday. So this is why we are doing take 4. First and foremost, it tells us right here a 2 by 3 matrix to show the data. So that means we have 2 rows and we have 3 columns. Well, that makes it pretty easy to figure out as to what they want us to write for the rows and for the columns. We have wins and losses, so that's going to represent the 2. So I'm going to put win here, and I'm going to put loss there. If you wanted to just do W and L to represent those, that would be okay. And then we have 3 participants, so let's go ahead and label those columns: Ed, Joe, and Lou. Okay, so Ed, how many wins did Ed have? A win is signified by a check mark, so that's 1, 2, 3, 4, 5. So we have 5 wins, and we have 1, 2 losses. Okay, Joe has 1, 2, 3, 4, 5, 6 wins, and he has 1 loss. Lou has 1, 2, 3 wins, and 1, 2, 3, 4 losses. Okay, so that is using a data to display data that was presented in a chart. Like I said, just another way to present that data. Okay, and finally, example 4 is using an example from the Olympics and scorekeeping at a gymnastic event, to be more specific. What's interesting about this is that it's pretty much the exact same thing as the table, with the exception of it doesn't have the defined borders of the columns and rows. And you have the brackets that signify that this is a matrix. Okay, so each row, as it says, represents a different gymnast, just like up here in that table. And each column represents a different event, just like the table. Okay. All right, so now let's go ahead and do this one then. Looking at the table here, U.S. passenger car imports and exports in millions for the years 1980, 1990, 1995. A says write a matrix N to represent the information. All right, we can do that. So we know it's an uppercase N because it's a matrix. Let's go ahead and just keep it like that. So we're going to do a 2 by 3. Imports will be my first row. Exports will be my second row. We've got 3.116, 0.617, 3.945, 0.794, 4.115, 0.989. Okay, now each column represents a different year. So we have 80, 90, and then we have 95. Okay, now look at B. And it asks us which element represents exports for 1995. Okay, so we want to look for the exports. And in this case, exports is in row 2. And then the 1995 is in column 3. So for part B, we know that we're going to use the lowercase letter. So that's going to be little n. That's going to be row 2 and column 3. All right, so hopefully your introduction to matrices has been fairly painless and not too bad. If you have any questions, you know how to get in touch with me.